Hi, everyone, and welcome. Thanks so much for taking some time out of your day to join us. I'm Ned Sheeran. I'm the Vice President at Allegheny Educational Systems. And for those of you who don't know us, Allegheny's been serving schools and colleges across Pennsylvania, New York, and New Jersey for 46 years now. We're focused on bringing innovative technology to the classroom. In fact, we're one of the very first companies to sell 3D printers to schools more than 20 years ago now, back when we were selling printers from this little company called Stratasys, who we still partner with today. Since then, we've represented a lot of great 3D printer companies, but honestly, we've never seen a printer with the sheer capability that we're about to show you. Imagine a 3D printing system that can print hundreds of parts using multiple materials and colors, and even automatically remove and replace its own build trays, all while the operator's busy doing something else. Carnegie Mellon University discovered this system, as did Rochester Institute of Technology, and that's what we're here to show you today. We're so excited about our newest 3D printer company, Mosaic Manufacturing. Mosaic is a company that's truly reshaping the supply chain with their scalable additive manufacturing solutions. And today they're going to give us a virtual demonstration of the Mosaic Array 3D printing system. Leading today's presentation for us are Farah Sultani, Mosaic's Partnership Manager for Education, and Robert Tillman, Senior Sales Engineer. Just a quick housekeeping note before we get started. We set aside some time at the end of the presentation to answer your questions. So as they come up, please just type them in the question box at the bottom of your screen, and we'll answer as many of them as we can. So now let's get started with our presentation. And Robert, I'll hand it over to you.
Awesome. Thank you, Ned, for the kind words and intro there. So as mentioned, we're going to be running a quick little demo today. So just a brief overview of what we're going to cover. I'll start off going through a PowerPoint presentation, just highlighting who we are as a company, our products, the software itself, and then I'll actually jump over to the array system itself in person, give us a real walkthrough of the system, how it all works, and then I'll pass it back over to Farah here to go over some of our success stories with customers, as well as, again, go into all the questions that we have at the end here. So jumping into things, as Ned mentioned, this is Farah, this is myself, so our partnership leads, and I am our senior sales engineer here at Mosaic. So jumping into it, who we are, I'll pass this over to Farah, and she'll take it from here.
Of course. Hi, everyone. My name is Farah. Pleasure to be here today talking with you. We have some great things planned for the webinar, and stay tuned for the end where we'll showcase the array live. But just to tell you a little bit more about us at Mosaic, we were founded in 2014, and over the past couple of years, our team has grown a lot. So we're now sitting at over 80 employees altogether. Overall, we've raised over 40 million to date and hold over 23 patents in automation and material management. So we really are doing something very unique here, and we want to be able to bring it to lots of different education facilities, yours included. Our goal here is simple. It's to reshape manufacturing and supply chains to be faster, to be localized, and more sustainable as well. And moving on to the next slide here. Want to also quickly cover our global presence. So to date, we've shipped over 15,000 hardware products altogether, and also globally to over 45 different countries. Here we have a list of some of the companies that we've worked with, and this covers a wide range of different verticals, from government to education to defense and aerospace. And you'll see some higher education clients that we've worked with in the past year as well. One thing I want to note too is we have customers both in higher education, like I mentioned, but also in a lot of manufacturing landscapes as well. So when we have an array at a engineering lab or at a school, a lot of the students will be able to learn a lot with the hands-on with the array and be able to take that into real world applications as well beyond the school, because again, we can see this application both in schools and in the real world as well.
So I'll take it over from here. I'm going to go walk into just the array through a quick little PowerPoint here before we actually jump over to the real field itself. So taking a look at array, what is it? So we can see in the picture here in the center, you can think of array as a print farm in a box. In here, we have 4 independent 3D printers that are all doing that are all capable of printing their own things separate from one another. And we have a robotic system that will actually take out finished prints, move them into a storage area, and then restart that next print, really just reducing any need for operator involvement throughout the entire 3D printing process. When it comes to the printers themselves, every printer inside of the array is capable of printing high temp materials such as PEEK or PEC. They have hot ends capable of 450 Celsius, beds that reach up to 120, and actively heated chambers that can go up to 80 Celsius. Again, really just helping with printing things like those high temp materials, or if you're maybe trying to print things like a large ABS part, really trying to reduce warping by having that heated chamber. Each printer inside of the array has a 14 by 14 by 13 inch build volume, so quite large. And then we have that storage system, as mentioned before, in the bottom left of the system. And the way that this has been designed is to hold a minimum of 72 hours of prints, meaning your lab managers can set the array up on a Friday morning, have students queue up all of their prints to the system. They can go about their day doing other more important things than operating and managing printers. All the while, the array system over the weekend will continuously print all of those parts with no operator intervention. And then you can come back on a Monday morning to a storage cart full of finished builds ready for students to come and pick up. So taking a bigger look, or a little step back here and a look into the array system. So again, we have 4 3D printers. So we have one in the top left corner here, and then 3 printers in the column on the right here. So each one of these printers is completely individual from one another. So I could be printing PLA on my printer in the top left, and I could be printing PEEK on my printer beside that. So our robotic system not only removes finished parts and stores them away, but it also manages the chambers of the printers as well. So every printer does have a chamber and an industrial enclosure. So if you are printing PLA, it can maintain a cool temperature, keep that door open. But if you are printing, let's say, ABS, PEEK, or PEC, it will make sure to close that door and ensure that temperature stays inside the printer, ensuring you have high quality parts. As we can see here, we have the storage cart below that first printer. So there is the ability, or sort of a storage area for 40 fresh build trays to be used. So this means you'll get a minimum of 40 prints before that storage cart is going to go and fill up. And then right below that, we have the gantry here that actually services those printers. So that's adding and removing print jobs from the system. Taking another little outside look here at the top left corner, we have this status light. So you can think of this similar to a stack pole on many more industrial things like CNC machines. But essentially, this is doing the same thing, giving operators a brief overview of the status of the array without having to go and physically interact with the system. And then we have our touchscreen on the front here. So if an operator wants to go and take a look at what's happening without going through the online software Canvas, they can do that physically on site with the array system. Now, taking a look at the rear of the system, this is actually probably the more interesting or more useful area for operators. So every single printer inside of the array system can hold up to 8 materials or 8 different filaments or colors. So this is really valuable for material management and just ease of operation in a lab. So where we see a lot of schools kind of run into issues, if some schools, they simplify everything to, we're only printing white PLA, that's all the students get. But when you open it up to different engineering departments or different faculties and everyone needs to be using different materials, it can become really cumbersome to have a student submit a file that needs to get printed. Now someone has to go to that printer, change out that old material, reload that new material. With the array system, all of our materials have NFC tags on them. So when they're connected into your system here on the backside, we know what material it is, what color it is, and how much is left on that spool, so we can make sure every job will be able to finish. So a really great feature of this is, let's say if you're printing, your school is printing tons of PLA and PLA only. You could load up 8 kilos of PLA per printer. So when one spool runs out, it'll automatically jump over to the next one. But maybe you're running in a very high mix environment where you have some students who want to print in PLA, but you need other students to be printing in polycarbonate or carbon fiber nylon. You can connect different spools to the same printer, and as the prints change within the queue, we will automatically switch over those materials for you, just reducing the need for operator intervention and really giving time back to any lab managers or TAs or professors to do more important work than run a print farm, because there's always more important work to be done than just changing out materials or taking out build trays and setting up printers to run again. So why educators really trust Array? So some of the big features here, obviously automation. We can really maximize that productivity without the need for that operator intervention. When it comes to scalability, this is really useful because it's so seamless. As your demand grows, Array will be there to support you. You're not having to add more labor, get more printers. We see this a lot with schools, for example, like UT Dallas, where they were having very large sort of seasonal swings in the demand. So as classes come to the end and projects are all coming up sort of due in a week, they were really running into issues where now they need to have more lab managers on site, but it's the end of the season, so it's kind of harder to get more student volunteers to kind of come in. Whereas with the Array system, regardless of how much volume is coming in, the actual work on the operator side stays the same. As I was mentioning before, material flexibility. So having that ability to print something like PLA, so you can have low cost, easy to print options for maybe first year students, but having that ability to print advanced engineering grade materials you're going to see in the real world when you go to work at Boeing, Airbus, or any of those bigger aerospace companies. Being able to print with materials like Peak and Peck becomes really valuable for both research as well as just teaching students sort of what exists and will be used sort of in the real world. As well as rapid deployment. A lot of systems can be rather cumbersome to set up, especially some of the bigger, more advanced 3D printing systems like in the metal world or SLS world. Whereas with the Array system, we can actually deploy this on-site within a day, have it fully built up, and then have an on-site training the same day we build that system, making sure you and everyone in your organization is ready and knows how to understand how to use the system. And lastly, and probably the most important thing, when it comes to the Array system, we have built robust software specific to the education space, which I think is something that lacks a lot when we talk about sort of the other sort of print farm setups that we'll see, or schools that are just buying multiple desktop printers and then there's no true, easy, scalable way to actually manage multiple printers with. We've seen people use USB sticks where students are coming in and they're just randomly throwing on files, hoping they print, or every single print that a student wants to do, they have to bring their laptop in, they have to walk the TA through their system, what they're trying to print, what settings they used, and it just becomes a really big burden on the sort of management side of things. So creating this software was really important for us to make it as easy as possible for schools to really get the most out of the system, again, without having to scale up sort of the labor aspect of their labs or maker spaces. So speaking on the sort of software side of things, I'd like to introduce to you guys Canvas Education. So again, this is our academic version of our software that has been tailored for education, really just aiming to streamline submissions and the reviewing of projects from students. So we give teachers and TAs really the ability to set guidelines and provide direct feedback to students remotely. So you don't have to be on site with them to actually take a look at their projects, set guidelines of what can be used, and really just it all makes for an efficient way to manage your 3D printing labs. So really it's just a smarter way to run your 3D printing lab. So it gives the control and visibility and automation you need to manage students without having all of the chaos of you have certain lab hours where every student's coming in and trying to get access to the systems, and there's no good way to queue them. It's really hard for you to sort of review every single student's project when there's no way to lock in what they're doing. As well as a very big feature of this is the ability to use the university logon. So as I'm sure many of you here, all of your schools likely have SSO, and we can integrate directly with that. So this means there's going to be no new accounts or passwords. Students and faculty can all log in securely with their existing credentials. So what's really nice about this is, again, you can stay hands-on without getting buried in the management of printers. So with Canvas Education, we can set up projects or course folders in a matter of minutes, and I can show you in this next tab here. So, well, I would love to show you guys a full demo of the Canvas Education system right now, don't have all the time in the world, but if anyone is interested in getting a full one-on-one tailored sort of intro into all of our software, please feel free to reach out to anyone on the Allegheny team at the end of this or anytime in the future. We'd be happy to set that up and walk through with you. But from a high level, the way we can think of Canvas education is you can essentially create Dropbox links that you can send out to students that will essentially give them a submission folder. So they'll click into this, it will take them into our slicing software. And then based on how you set up this folder, these students will be restricted to certain things, such as you can lock in default print settings. So maybe if it's a first-year print class, you just want them to learn about how 3D printing works. You don't want them to change settings like layer heights, print speeds, infill settings. Or maybe it's a research graduate class and you want to have them to have full access to every single setting in the slicer. You can then open that up to every single setting. Or you can even have the option to say, you can choose your layer height, but it has to be between X and Y. Something else that we get the ability to do is limit the number of parts. What is the budget per submission? So maybe you don't want students printing a $500 print in peak. You need to make sure that every submission is under $10. We can also restrict to just approved materials, again, making sure that students are printing in the materials that you need for that class. And then lastly, you can require submissions to all come from a school's domain. There's a couple other features, so things like due dates that we can set up. You can just write in notes. And something to note is you can't just create one link for everybody. You can create multiple submission folders for different classes or different faculty, whatever that may be, all with different sort of varying permission levels. And then the really nice part about this is once students go to submit all of their files, you can view everything from a centralized dashboard. So we can see here in this photo here, this is the submission folder for this one class, the APSC 311A. And we can now track participation and manage this class with ease. So we'll see every single student submission down in the bottom here, and I can click into them. It will open it up in the slicer view for me, and I'll get a checkbox basically inside the slicer, making sure that did the student hit all of the criteria that was set, whether that be print time, cost, or number of parts on the bed. And from there, I have the option to approve that part and send it to the array system. The student will get a notification their part has been sent to the system and will be notified when it's ready for pickup. Or maybe I noticed the student never turned on supports for this part and their print will fail if they don't do that. I have the option to reject that submission. It will send them an email, and within that email, you can also write a note. So through the software, I can write a note and say, hey, you forgot to turn on supports. This print won't work without it. It'll automatically go back to the student. They can make those changes, automatically hit send. It will come back here into the submission folder, ready for you to review and accept or reject that project again. So this really just reduces the overall labor aspect, because that is one of the largest complaints we hear about a lot of these labs in pretty much every school we've worked in is there's never been a good way when you have, let's say, 100 students all trying to bring files over to their printers. There's no good way for the teacher to know how they were sliced, what it was done, unless they're very, very locked down in what the students are doing, or they're there watching them do it as it happens. This gives students the ability to slice their projects up from anywhere in the world, and also gives the TAs or the lab managers that ability to review these from anywhere at any time without having to be restricted to certain lab hours or being on site with students. So before I jump into the array system, I'm going to pass it back over to Farah just to cover over a couple of the customer stories.
Awesome. Thanks, Robert. So one great example of success with Array in an education institution comes from UT Dallas, where their 3D printing lab went through a major transformation with Array. So before Mosaic, they faced real challenges. Limited print throughput led to long wait times. Staff had to come in on weekends, just how Robert was mentioning. They'd have large print queues near the end of a semester or near the end of a project submission, where everybody's submitting it and there aren't enough printers to be able to print. So they had to put in more work, more time to be able to get it done. And high printing costs also restricted them in the types of projects the students and the faculties were able to take on.
And I
And
need you to key me in, Catherine.
Robert, we can hear you there. But and then after Mosaic, after we put an array into their facility, the lab is now on track to surpass their record high print volume in a single year. And that's without adding any new staff onto their team as well. Automation and remote management completely eliminated the need for weekend work, coming in after hours, and the ability to produce large multi-material engineering grade parts at a much lower cost per part. UT Dallas was able to expand what's possible for both their students as well as their researchers as well. Another great example is at Carnegie Mellon University, and we saw how Array can transform an education program there as well. Before Mosaic, CMU, Carnegie Mellon University, relied on desktop printers, which meant very limited throughput and also frequent backlogs, similarly to what UT Dallas was running into as well for both students and the faculty. Managing print queues was a very manual process for them, and again, caused a lot of delays and administrative bottlenecks as well. And as their creative and multidisciplinary programs grew, they found it increasingly difficult to be able to manage what was coming in, but to also scale further going forward with operations and to try and meet those demands as well. And after adding an array at their facility, it definitely made a huge difference in their day-to-day operations. Having an automated high volume printing enabled and streamlined a lot of their processes going forward as well, giving students and faculty access to the parts that they needed. Remote management and also the intelligent queuing software that's available within Canvas eliminated a lot of their manual oversight, and therefore, of course, freeing up a lot more time for staff and students to be able to take on additional projects that they want. And most importantly, Array really enabled CMU's ID8 program to really scale, supporting a lot more cross-disciplinary projects and innovation across the university as a whole. And with that, I will pass it back to Robert for the live Array demo as well.
All right, well, thank you, Farah. So welcome, everybody. We're now actually in front of a live array here. So as you can see, it's quite a big machine. So it's about 7 feet tall, 6 feet wide, 6 feet deep. And taking a look at it from the exterior, as I mentioned before, in the top left, we have that curved status light. So this shows us just the current status of the system. Green, all systems are go. We have plenty of materials left, plenty of storage left in our storage cart, and fresh beds ready to go. Yellow might mean we're running low on materials, and red would mean either we're out of material or we are simply out of storage cart space and it's time for an operator to come and interact with the system. Taking a look below that, we have our touchscreen here. So many of the features that are available on Canvas are also fully accessible through here. So if I want to take a look at my queue, I can see what's in order to be printed here. I can readjust things. So if there is high priority jobs that come through, we can make adjustments to the system through here. I have the ability just to go into every printer individually. If I want to cancel prints, change prints, or just manually move things around, extrude filament, all of that can be done through here. As well as we can take a look into our storage cart, and it will tell us how many fresh beds we have left, how full it is, what parts are actually stored, and where they are inside of the system. And then we also have a settings page just for things like updating your firmware, changing your screen brightness, connecting it to Canvas, or other things like that. And then below our touchscreen here, we have an emergency e-stop if you ever need to turn off the system, as well as we have a power switch here, as well as a USB stick, although that's typically used for people who are running the system in an offline configuration in more security-focused environments such as aerospace or defense. Now, taking a look at the side of the array system, on both the left and the right sides, we are completely free of any access panels. So this really opens up where we're able to place the system, meaning we can go against a wall or in between two existing machines. The only areas where we actually need to have access is on the front and the rear of the system. So opening up the array, we now get our first look into all of the printers. So again, we have one printer in the top left here, and then we have a column of 3 printers here on the right side with our gantry here that actually services the prints. Now, below our first printer, we have our storage cart. So this is where all of the finished prints are stored. So as we can see here, we have a variety of different prints. So we have some PLA prints there, we have an orthotic being printed, and we also have a peak print up top. So as I mentioned, you're able to print a variety of different materials all at once without having to have operators come in, manually change things out within the printers. This becomes much easier for big labs or maker spaces to offer a much wider variety of materials to students without having to take on a large amount of work themselves to actually maintain the printers and have them set up for those different materials. So taking a look at the storage cart a little bit deeper, as I mentioned, you can hold up to 40 beds inside the system. So you have all of your beds will be stored in this top slot here. And then as the gantry system takes them out, it will put them into that cart. And we know the height of every single print. So this allows us to densely populate that cart, giving you a minimum of 72 hours of lights out production. So again, you can start up your array system on a Friday morning, have people send their queue of parts to it, and come back on a Monday morning to a storage cart full of prints. Now, again, taking a look at the printers. So these are all 14 by 14 by 13 inch build volumes. And as we can see here, these are all currently printing PLA, so the doors are open. But if I was printing PEEK or another material such as like ABS, the gantry system can actually go in, close these doors, and make sure that the printer is fully sealed off from the rest of the environment around it. And if you are using the heated chamber, it will keep the heat inside of that printer. Now I'm going to jump around to the back side of the system so we can take a bigger look at where operators are going to spend more time with the array. So jumping into the back side of the array system here, we get our first look into where the actual materials are coming from and how they're connected to the system. So as we can see here, all of these printers only have 2 material pods currently connected. But as I mentioned earlier in the call, every printer has the capability to have up to 8 material pods connected to them at any given time, meaning you can have 8 different materials ready to print at any time, or you can have run out. So when one material runs out, it will automatically jump over to the next one, making sure that material is ready to go. Now, taking a look at the storage cart from the rear here, we can see there's actually handles here, and the entire storage cart is fully removable as the system is on wheels. So this means when your cart is completely full, I can come in here and I can actually slide out my entire storage cart, bring it to a separate area, have it ready for students to come pick up their parts. And once I'm done, I can then go slide it back in, and we are now ready to go and start printing again. Something that we see a lot in sort of high volume manufacturing or even the education space is customers buying 2 storage carts. So when one's full, they can take it out, leave it beside the system. They can wait for students to come pick up all of their parts, while they'll have another storage cart sitting inside the array, ready to go and continuing that production, while that other storage cart is waiting for students to come and pick up their finished prints. Now, the other piece of the action that an operator would be involved in is actually replenishing the materials. And to do so is very simple inside the array system. So all of these material pods connected to array have a simple latch here. If I click this, I can just pull my pod directly out. And then we'll see here, we're actually just using standard filament spools that just fit inside of the system here. And something to note is these material pods are gasket sealed and they are humidity controlled. So when I take my filament out of its vacuum sealed packaging and I place it into here, I know my filament is going to be maintained, it's going to be dry, and this way we can ensure quality prints for the duration of the array or for the duration of that material being inside of these pods. You're not going to have to worry about humidity ruining your prints, unlike some other printers where they just leave their filaments exposed to the environment. When I'm ready to reload my filament and put it back in the printer, I simply drop on my lid and I can click this right back into the printer. It will now read what material I just added to it and then now tell the system, hey, I have this white ABS ready to go. So the next time a part comes up in the queue for white ABS, the array system will be ready to take that on. So that's everything I wanted to cover for the array today. As I know we don't have all the time in the world, but if anyone wants to have a deeper dive or a pure one-on-one demo of the array or any of the software features, again, reach out to anyone on the Allegheny team and they'd be happy to set that up with us. For now, I'll pass it back over to Farah and I'm going to come answer your questions in the other room.
Amazing. Thanks, Robert. That brings us now to the end of the presentation. So we will pass it over to Ned to read over some questions that we might have gotten.
That really was amazing. I'll tell you, I think that's the coolest thing I've ever seen. Every time I watch the demonstration, I'm just amazed. Thank you very much, Robert, and thank you very much, Farah. We do have a couple of questions. All right. Here's the $79,995 question. How much does it cost? That actually is the starting price for the array. It depends is the real answer. It depends on what configuration you're looking for, the number of material pods, as Robert said, the number of rolling mobile carts that you get, the different types of element print heads that you want configured in your array. So it's a range somewhere from 80,000 to 120,000 or so is the range. And we're happy to get you a price list or to actually get you a quote that's customized to your application. So our email address and phone numbers on the screen there right now. Shoot us a message. We're happy to help you with that. So let me see what other questions. What materials can Array work with, and what do most schools print with on Array? And I turn that over to you, Robert.
Yeah, absolutely. So Array is compatible with a wide variety of materials. So as I mentioned earlier, we have a hot end capable of reaching 450 Celsius and a bed of 120. So this really unlocks a lot of materials, anywhere from the most basic PLA up to things like carbon fiber nylon, polycarbonate, or even up to those industrial grade materials like PEEK and PEC. Comes to what schools are printing, I think everyone knows, I'm sure everyone here, PLA is probably the most common material, comes in a wide variety of colors, very forgiving and easy to print. So when you're a design lab or a makerspace, you want something that's low cost, easy to print. But again, that makes a lot of sense for certain classes. But when we start looking into sort of schools doing applied research or more advanced mechanical engineering courses, people need to have access to more industrial grade polymers that you're going to see in the real world. When you go to work at a business in manufacturing, they're not going to be printing in PLA. They're going to be printing in fire retardant polycarbonates. They're going to be printing in carbon fiber nylons, all sorts of flexible materials, or again, even up into those materials you'll find in satellites like PEEK and PEC. So we do cover sort of the entire gamut of materials when it comes to that FDM printing space.
Great. Thanks, Robert. All right, we do have another question, just one more question. If you guys have more questions, please put them in the question box. Happy to answer them. If it runs unsupervised, what is the role of the operator?
Yeah, so while the array runs unsupervised, doesn't mean there is no operator requirement involved. So where we see operators being used is one, as I was showing you with the Canvas education, you need to be sort of approving or rejecting submissions as they come in from the students and making sure that you have a storage cart that has fresh build trays ready to be printed with. You have materials ready to go. So as I showed at the end of the demo there, you want to be ready or be aware of how much material you have connected to your system, because we can't print your ABS print if you have no ABS connected to the system. So while there is much less work for operators in terms of they're not changing up build trays, they're not constantly swapping materials, there is still a job for them. Don't worry, we're not going to completely replace you just yet.
And we just got one more question. How can I get a demo of Canvas Edu?
So as I mentioned earlier in the call here, at any point, feel free to reach out to anyone on the Allegheny team or Farah at the Mosaic team here, and we'd be happy to schedule a one-on-one demo with you. We can walk through all of the nitty-gritty details of how the actual slicer works, the materials management, device management, and many more of the sort of robust feature sets that you would see inside of Canvas Edu.
That's great. Well, that's it. I see no more questions. I just want to thank you both very much, Robert and Farah. This is it's just way cool. It really is cool. We're really, really proud to be partnering with Mosaic Manufacturing. As I mentioned at the start, Allegheny Educational Systems is Mosaic's partner in Pennsylvania, New York, and New Jersey. If you're a school in one of these 3 states, certainly get in touch with us. If you're outside of our area, still get in touch with us, and we'll forward your information to Robert and Farah so they can reach out to you as well. So one last time, thank you all for joining us. Robert, Farah, thanks again for presenting today this really cool system array.
Yeah, absolutely. It was our pleasure. And again, would love to hear from you people and give you a tailored one-on-one demo.
Thank you.